Welcome back. Today we're going to talk about lines and angles, and lines and angles relate in certain ways that are going to allow us to talk more easily about them. Let's talk about parallel lines first. Parallel lines, as you can see by this little diagram, that's the symbol for parallel lines. Parallel lines are coplanar lines that never intersect. So they're coplanar lines that never intersect. For example, put a little blue star by them. These are parallel lines. Okay, so I'll call this M and I'll call this N. So M and N are parallel. And I'm going to mark them with little arrowheads in the middle to say that they're parallel. So they each have one arrowhead in the middle, which means they're parallel. Marked with an arrowhead. Perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle. Intersect at 90 degrees. So that would be like this. And they're marked with this, whoops. They are marked with this 90-degree symbol because they're intersecting at 90 degrees. Skew lines. Non-coplanar lines that do not intersect. That's the key. They're non-coplanar lines that do not intersect. So if I stick one line on here like this, the other one would have to come up sort of like this, and obviously it would bash through the plane underneath. Okay? So we've got one like this and then one that kind of jets off like this. They don't intersect. And so even though in the picture, the dotted line looks like they intersect, remember that dotted line goes straight down through the plane. And so skew lines are non-coplanar. They don't intersect. Parallel planes. Two planes that do not intersect. So I'll just draw a plane behind here, and you can see that they don't intersect. It'd be kind of like this. Okay, so you've got two planes here, and they're not going to intersect. So no matter which way I turn them, they run parallel, they don't intersect. Okay, sometimes when we draw these planes underneath, we kind of do a little bit of shading to show which one is behind. Let's do an example. Here I have this cube, and I've put each of the intersections of the sides as a line, and each of the vertices of the cube as a point. And you'll see here I have like a 90-degree angle here. A couple of other features. I have some arrowheads here, these blue ones, meaning that FB and EA are both parallel. And on EG and FH, I have two arrowheads, meaning that those are parallel. So let's say a pair of parallel segments. Well, it asks me for segments, so I need to name them as such. So I'm going to say segment EG and segment FH. Those are parallel segments. There are many others, but those two are marked parallel, so I'm going to use those. How about a pair of skew segments? Remember, skew segments are non-coplanar. So what if I chose segment AE? So AE's up here. I need one that's not going to be coplanar with that. So I'm going to choose segment FH. So AE runs like this, and FH kind of busts up this way like that. So no shared points there. That's the key to being skew. A pair of perpendicular segments, well, I've got these marked here with a 90-degree angle, so I'll just use those. Segment EG and segment GH. Pretty cool. A pair of parallel planes, planes that are parallel, meaning they don't intersect. So I'm going to name these planes. So plane, how do we name planes again? Oh yeah, 3 points. Plane AEG and plane, so AEG, so it's this side over here that I'll mark with blue, and this other shaded plane here. So plane BFH. Could have named it in another way, but that's okay. Many examples of this in this little diagram here. It's a beautiful diagram because it has lots of examples. So maybe you didn't have these ones specifically, but these are examples of those. A little bit more vocabulary. This diagram over here is what we call lines cut by a transversal. And a transversal is a line that intersects two coplanar lines at 2 points. Line T is a transversal. Okay, so line T is a transversal. R and S are those coplanar lines, and T cuts them and intersects them at 2 points. 8 angles are formed. That's huge. 8 angles are formed, and I already have them labeled for you. 1, 2, 3, 4, 5, 6, 7, 8. Because these are the types of angles that are formed. Corresponding angles. Corresponding angles. In order to talk about these 4 types of angles, I need to understand interior versus exterior. Interior is inside the 2 lines that are being intersected. Exterior is on the outside. So exterior, and this is also exterior. So exterior is on the outside of the 2 lines, interior is on the inside of the 2 lines. And so corresponding angles are just in the same relative position in both x's. What do I mean by that? I like to think of this, if I was going to pull out these 2 boxes here, look at what happens. I'm going to draw those 2 boxes. I like to think of them like windows because they have basically 4 panes, which are the 4 angles, and so they're kind of divided like this, right? And so I've got these 2 x's that are formed. Well, there's 4 angles in each x. Here's how they're labeled. 1, 2, 3, 4, and then 5, 6, 7, 8. And you can see that they correspond because there's like the left part and the right part and the top part and the bottom part. And so when I'm talking about corresponding angles, I'm talking about ones that are in the same relative position. For example, 2 and 6 are both in the upper part. And so then 1 and 5 would be in that left-hand part. And so 4 and 8 would be in the right-hand part. And 3 and 7 would be in that bottom part. Okay, so that's the same relative position. Alternate interior. Alternate interior angles are on alternate or opposite sides of the transversal, but they are on inside of two other lines. Okay, so look at what the name says. Alternates on opposite sides of the transversal. Opposite sides of the transversals, like 3 and 4 are alternate angles, 5 and 6 are alternate angles, and then they're on the inside of those two lines. And so if I'm looking at what are some examples of alternate interior, like 3, so remember this is the transversal, okay, so these kind of go like this, right? Inside and alternate, so 3 and 6 are alternate interior, and 4 and 5. So they have different names. They're relating to each other in different ways. Alternate exterior angle, like you guessed, they're opposite sides of T, the transversal, outside the two lines. Okay? So, for example, these would be like outside, so 1 and 8, and 2 and 7. Because they're outside or exterior, 1 and 2 are exterior, 7 and 8 are exterior, and 1 and 8 are alternate, 2 and 7 are alternate. Same side interior, like you guessed it. Same side of T inside R and S. So they're inside R and S, they're going to be like 3 and 5 and 4 and 6. This is one of those things you just have to practice because the naming of these things is really important and it just takes some practice. So let's do an example here. I've given you 8 angles here. So we have 2 lines that are cut by a transversal, and so I want you to name an example of each of the following corresponding angles. Remember, if I drew these windows on here, corresponding angles are going to be in the same relative position. So like 1 and 5, upper left, 2 and 6, upper right, 3 and 7, lower left, 4 and 8, lower right. Alternate interior angles. Remember, this is interior and this is exterior. Okay, so alternate interior angles are going to be like 3 and 6, 4 and 5. Alternate exterior are going to be like 1 and 8, 2 and 7. Same side interior like 3 and 5, 4 and 6. It doesn't really matter how they're numbered. It's about the relative position. And so I want you to do example 2b on your own. I've given you the angles. Draw your windows in if you need to. And remember what it means to have interior and exterior. All right, guys? Thanks for watching. We'll see you next time.